Hi everyone, in this video we're going to find the domain of the log of x cubed minus 81x. So first note that if it was just the log of x, the domain would be all the positive numbers. So x here would have to be greater than 0. Okay, so here it's the log of all of this stuff. So this whole expression here has to be greater than 0. So the first step in a problem like this is you take this entire expression and you set it greater than 0. That's step one in a problem like this. Always, whenever you're looking for the domain of a logarithm, that should always be your first step. You take whatever is here and you set it greater than 0. Now, to solve this inequality, there's a couple ways to do it. We could do it graphically, or we could do it using something called the test point method. So let's go ahead and do it this way. And the test point method is okay. It's not hard, but it takes a bit of work to understand it. But it's worth it because if you understand the test point method, you can do almost all of these problems, or probably all of them. So the test point method says that the first step is to make sure that you have a single term on one side and 0 on the other. So here we have two terms. So let's try to factor. It looks like we can factor out an x, and that will leave us with x squared minus 81, and that's greater than 0. And it looks like we can factor even more. This is the difference of squares. So this is x, and it's x minus 9, and then x plus 9. And this is greater than 0. So now we have a single term on one side and 0 on the other. So the first step in the test point method is done. The second step in the test point method is to take each of these factors and set them equal to 0. So we'll set x equal to 0, x minus 9 equal to 0, and x plus 9 equal to 0. This is often a source of confusion. People are often confused as to why you do this. Why here do we have a greater than, and then all of a sudden we have equals here? The real answer is because we're just following the steps in the test point method. But the reason that this is the second step is because we're looking for when this expression will change sign. In other words, when is it going to go from positive to negative or negative to positive? In any case, if it goes from negative to positive or positive to negative, at some point it has to be 0. So when it's equal to 0, that's precisely the moment when it will change sign, right? So always key to look for where it changes sign. So we have x equals 0, here we have x equals 9, and here we have x equals negative 9. Okay, now you'll see why it's called the test point method. We take each of these numbers and we plot them on a number line. So here's negative 9, here's 0, and then here's 9. And then we pick an easy number. Let's pick 1. So let's check 1. This is a trick, by the way. I'm going to show you a shortcut to save hours on your life. So I'm just picking an easy number that's not one of these. So 1 is a good choice. You can pick any number you want. So we'll take 1. As long as it's not these, you can pick it. And you can plug it into this one or this one down here. I'm going to use the top one. So 1 cubed minus 81 times 1. And we want to see if that's greater than 0. So that's 1 minus 81. And we want to see if that's greater than 0. So 1 minus 81 is negative 80. And is that greater than 0? No way, right? No, no, no. It's not greater than 0. So here's what happens. We picked 1 from here, right? Between 0 and 9. It's not true. So we shade over here. And this is a cheap trick, okay? So now the pattern is shade, no shade, shade, no shade. Again, because it wasn't true, we don't shade here, and we shade in the one over here and the one over here. And the pattern will always be shade, no shade, shade, no shade, shade, no shade. So again, it's not true, we don't shade, then we shade here, we shade here. If it was true, let's pretend let's pretend, just to make the point, let's say that it had been true. Let's say it had been like 80 bigger than 0. Oh, okay, so 80 is bigger than 0. So what do we do now? Then you would shade here, no shade, no shade, shade. Because the pattern is always shade, no shade, shade, no shade, shade, no shade. That pattern will always work unless you have something here to an even power, like an x squared, or here there's a 2. But that doesn't happen, right? If you have something like this, game over, right? You can't have a 2 here. You'll have to do it each time. So what happens when you have something like this? Well, you have to pick a test point in each piece. So it's 1, 2, 3, 4 test points that you have to check. And if it's true, you shade. If it's not true, you don't shade. This method, this cheap method, allows you to pick one. We picked one number. It wasn't true, so we didn't shade. And then we shaded here, and then there's the pattern. Shade, no shade, shade, no shade. We're done, by the way. Let's write the answer down. In interval notation, we use parentheses, and that's because it's a strict inequality. You'll pretty much always have parentheses when you have problems like this with logs, because you're always going to have a greater than. The answer is -9, 0, union 9 to infinity. So that would be the domain of this logarithmic function. I hope this video has been helpful. This is a much harder problem than people typically see. Good luck.